All right, this is Mr. Gilman. Today we're going to continue to talk about inequalities, and today we're going to learn about the negative rule. I know you're excited, but the nice thing about inequalities is that they're almost exactly like equations, except for instead of an equal sign, we have a greater than, a less than, a greater than or equal to, or less than equal to sign. And so what we do is we solve them the same old-fashioned way that we always have, two-step equations. So in this case, it just says solve and graph the problem. Negative 2x plus 5 is greater than 9. All right, and so since we're getting pretty good at these, let's go ahead and solve it like a two-step equation. I see an addition of 5, so I'm going to use subtraction. Negative 2x is greater than 4. And I continue on. I divide both sides by negative 2 because I see that negative 2 is being multiplied by x. So I know that x is greater than negative 2. So let's just pretend we did it like we always do. Nothing changed. It was all easy peasy, lemon squeezy. And then we got this open point on negative 2 because we know negative 2 is not greater than negative 2. And then we know that since the numbers go to the right and they get bigger and to the left they get smaller, we draw our inequality right here. Okay, and we were done. It was easy. However, there's a little flaw in our logic this time. All right. If I'm saying that my values that are greater than negative 2 are solutions to this equation, then when I plug in values, it should be true statements. So let's just try. Here's 0. 0 is supposed to be a true value of this statement. If I plug 0 in this equation, negative 2, this inequality, plus 5 is greater than 9, then I know 0 plus 5 must be greater than 9, but all of a sudden, look, 5 isn't greater than 9. So somewhere we made a boo-boo, all right? And that's where today's comes in, the negative rule, all right? Since I know that 0 is not a solution, I know that that can't be right. This whole side cannot be right. Let's try the other side and see if those work. Let's try negative 5. Negative 5 is on the left side of the open dot. Let's try negative 5. Negative 2 times negative 5 plus 5 is greater than 9. 10 plus 5 is greater than 9. Well, I know that 15 is greater than 9, so the side that I should have shaded was this way. Interesting. Even though my answer says greater than, I'm shading to the left. So what you're going to learn today is instead of plug and chug and trying to figure out which side to shade, there is a way to keep it consistent. All right, let's take a look here. If you multiply or divide both sides of an inequality by a negative, then the direction of the inequality changes. So now let's try this problem again. It's going to be the same steps in solving it as far as the algebra goes. However, this is the important step right here. Okay, everybody put a little star on your paper right there. I know you're listening. Okay, this step, we're going to divide both sides by a negative number. And this is where things change. Okay, when I divide both sides of an inequality by the same number, by a negative number, the direction of the inequality changes. So if it was opening to the left, now it is opening to the right. If it was a greater than, now it's a less than. So now, if I make sure I do that while I'm solving my equation, I can use the same rules I knew as always. When it goes to the left, it's getting smaller. When it's going to the right, it's getting bigger. Since I switched my inequality when I divided by a negative number, I know exactly which way my inequality needs to go. It needs to go to the left. All right, so you'll have to flip your symbol if you're dividing or multiplying by a negative number. Okay, that's very, very, very important. Only when you're multiplying or dividing by a negative. Okay, when you're just dividing by a regular number, no problem. Only when you're multiplying or dividing by a negative. So here we go. Let's take a look at some of these inequalities using the negative rule. We're going to continue to solve our inequalities the same way we've always solved equations. But as you can see here, on most of these problems, we're going to have to either multiply or divide by a negative. In this case, I'm dividing by negative 3. All right, and on the step that I'm dividing by a negative, that's the step I change the inequality sign. So it went from a greater than sign to a less than sign. All right, only when this number is negative do you flip the sign, flip the inequality. So in this case, we're going to go to negative 4. We're going to put an open dot because It's just a greater than sign or a less than sign, open dot. And this is my solution, so this is the one, not this sign. That doesn't tell me which way. My final answer tells me which way to draw my solutions. In this case, the less than side, so it'll go to the left. If you're not sure, try a test point. 0, this should make a false statement. It shouldn't work because it's not shaded. Is -3 times 0 minus 4 greater than 8?
Teachers and students, excuse this interruption. At this time, second quarter perfect attenders are released for lunch. If you are
Now, because I know that 0 was supposed to be a false solution, it's good that I didn't shade that side of the inequality. So I know I'm on the right track. All right, let's take a look at another one here. And in this one, I'm going to start by adding 5 to both sides because this does say -5, and I'm still trying to isolate the variable. All right, and now I'm going on. I'm going to divide both sides by 2. Now notice, when I divided this time, I'm still just dividing by a positive, so nothing is going to change. I'm still going to have less than or equal to. The difference between this problem was I divided by a negative. On this problem, I'm dividing by a positive, so nothing has to change. So my solutions are at 1 and including 1, so I'm going to put a closed dot and everything less than or equal to 1. Okay, so one more time. This one I changed the direction because I divided by a negative. This one I was dividing, but not by a negative, so I don't change the sign. All right. Now let's do this one with multiplication. I'm going to start by adding 2 to both sides of the inequality. Now I have -1/4 x is greater than -1. Now, I'm still seeing people do this. Divide both sides by -1/4. No, there's special rules for fractions. I don't want to see that on anyone's paper ever again. I'm going to make you redo it. Okay? What I want you to do is I want you to use your multiplication knowledge. I want you to take it times 4 over -1. I want you to multiply by the reciprocal. Okay? So I want you to multiply both sides by the reciprocal instead, because that, we know, will reduce everything out to just ones, and so all we're left with is just x. And on the right hand side, we have negatives cancel out, and we just have 4 over 1, which is 4. We don't need any negative sign at all. A negative times a negative is a positive, so 4. Okay. However, we did multiply both sides by a negative value. So what we need to do with our inequality is change its direction. And that's the important part that we're learning that's different from yesterday. Okay, instead of being a greater than like we started at the beginning, now my solution says less than. So I'm going to put my open dot on 4, and I'm looking for all the values less than 4. Those are to the left. And I need to make sure to put my arrow on here because they keep going forever. There's infinitely many numbers smaller than 4. Okay? Let's take a look at one more here. We'll start by adding 2 to both sides of the inequality. Right now, I'm on the right track, and now I'm just going to go ahead and divide by 4. And once again, I want you to notice that I'm not dividing by a negative. I'm just dividing by a positive. And regular division has no change in the inequality sign. Okay, it's still a less than or equal to sign. All right, so I don't change it whatsoever. Put a closed dot on 3, and less than or equal to 3. So all the values less than or equal to 3. So I need an arrow going to the left. I need to make it continuous because even though I didn't make the arrow all the way to -4, -4 is still a solution. So I want to put this arrow, and that's just going to include everything forever to the left. All right. So the big point for today was if you divide by a negative, you change the sign. If you multiply by a negative, you change the direction of the inequality. Those two rules happen. Regular multiplication division do not apply. You leave the sign alone. Only when it's by a negative number. And that's it for today.